Hello friends, welcome to my channel Learning Chemistry. So today we will talk about the Beckmann rearrangement related some tricky problems. At the same time we will also talk about some Beckmann fragmentations also. And you all know that Beckmann reaction or fragmentation is a very important topic as far as CSIR NET, GATE or IIT JAM exams are concerned. And every year there are some problems which are related to this Beckmann reaction or fragmentation. So I have previously made a video on fragmentation reaction. There you can see some problems which are related to Beckmann fragmentation. But after that I have decided to make a separate video on Beckmann rearrangement or Beckmann fragmentation based. So let's start. So here is our first example, where we are given an oxime where one of the carbon center is chiral. Now the reagent we got here is acetic anhydride. You know that acetic anhydride just acylates the OH group, making OH group a good leaving group. Okay, so let's just write the product. And now you can see that as the chiral group is anti-position, or you can say transposition with respect to the acetate group. So according to, you know that according to Beckmann fragmentation, that group which is trans to the leaving group will migrate to the N center, and the leaving group from the nitrogen leaves. So that is the important aspect. Okay, so and here is another important aspect, that as the chiral carbon which is migrating is chiral, so during the migration the configuration of that chiral carbon will be retained. So this is the main message from this problem, which is that the chiral carbon, the configuration of the chiral carbon will be retained. So let's just write the product. And now what happens in the reaction medium, the water molecules will be there which just reacts to the positively charged carbon. So we'll get ketone out of that. So this is our product. So now next move on to our next problem, where we are given a bridged carbonyl, so which is treated firstly with hydroxylamine and after that aqueous H2SO4. So as expected, that you know that the carbonyl reacts with hydroxylamine to give a oxime as a product. So let's just write it. And now the second reagent is aqueous H2SO4, so which just protonates the OH group, making it a good leaving group as water. So now what happens, that so there could be a chance of a rearrangement, but no group just migrates. So instead of migration, CC bond cleavage occurs. So there are two bonds attached to that carbon, so there are two options, but you can see the bridged carbon bond is connected to the bridged center, so that cannot migrate. So the other carbon, this carbon, that will migrate. So other carbon that will cleave. So if that carbon cleaves, that will generate a 3-degree carbocation out of that. So that is very stable, so that path will be very much favored. So let's just write that intermediate. So after the 3-degree carbocation formation, so there just an elimination occurs from the alpha hydrogen of that 3-degree carbocation. So let's just write the first 5-membered ring, and after that rest of the groups are as it is. So this is our product. Now let's move on to our next question, where we are given an oxime and acetic anhydride as a reagent. Now you know that acetic anhydride just acylates the OH group. Okay, so let's just write the product. And now what happens, the CC bond cleavage takes place. So now what happens, there is again a chance of a CC bond cleavage, because this is a Beckmann fragmentation there can occur. So there are two options, but you can see if the CC bond cleaves occurs from the benzylic carbon, so that will generate a 3-degree carbocation, as well as that the carbocation will be stabilized by the neighboring benzene group. Okay, benzene group, so that is very much stabilized. So let's just write the carbocation first. And after that, this is like the previous problem, the alpha hydrogen with respect to that 3-degree carbocation will just eliminates and we get our product. So this is our final product. Now let's move on to our next problem, where we are given an oxime and PCl5 as a reagent. Okay, so now you know that the PCl5 reacts with OH. So OH just attacks the phosphorus. OH group converted into a OPCl4, and which is also a very good converted into a very good leaving group also. And Cl- is liberated in the reaction medium. So now what happens, there is a CC bond transposition with respect to the OPCl4 group, and you know that according to conditions of Beckmann fragmentation or reaction, that CC bond is anti to the leaving group, will be more vulnerable to the cleavage or migration, whatever. So now what happens, that as that carbocation is very much stabilized, which is CHPH2, okay, so that is very stable carbocation. So what happens, that Cl- which is liberated in the reaction medium, that just attacks at that carbon, and that bond migrates to this center, and this OPCl4 just leaves as being a good leaving group. So we get this product. Okay, so now you can argue that why the Cl- is attacking like a SN2 fashion instead of the bulkness of the phenyl group. So this is nothing like SN2 reaction. I have just written it for the simplicity of the understanding. This is like a SN1 reaction, because that CC bond will be cleaved at first, generating a carbocation which is CHPH2. Okay, so after that the Cl- in the reaction medium, that will attack at that, but I have written in here in the synchronous manner just to simply understand the bond formations or the bond cleavage order. Okay, so this is a kind of abnormality of Beckmann rearrangement, or you can say Beckmann fragmentation. So let's move on to our next problem, where we are given an oxime which is reacts with SOCl2, which is here the same reagent like PCl5 kind of. Okay, so which is again reacts with the OH. And generating a group which is OSOCl, and another Cl- is liberated in the reaction medium, and also OH group converted into a beta leaving group. And now you can see that the CC bond, which is just transposition with respect to the OSOCl group, will be more vulnerable to bond cleavage. So as expected from the Beckmann fragmentation, so that CC bond will be vulnerable. So now what happens that at that CC bond there is a nitrogen center. So what happens, that nitrogen center, the lone pair attacks this carbon, and this CC bond being a vulnerable at just cleaves, moves to this CN bond, and here SOCl to OSOCl being a good leaving group, it cleaves. So we get a fragmented product, two products out of here. And that fragment will again hydrolyzed, and we get formaldehyde and secondary amine as another two byproducts. So these are our products from these reactions. So our next problem is, here we are given an unsymmetrical ketone which is reacted to first with hydroxylamine. So we get Oxime as a product, which is, so let's write it. Now here is an important aspect, that there is a carboxylic acid. So just a convention that you know that if a carboxylic acid group is present at the alpha position or near vicinity to some kind of unsaturation of bonds, get decarboxylated easily. So for that reason, that CC bond have to be very vulnerable to cleavage. So for that reason, we have to keep the Oxime OH to the trans to the COOH, so that CC bond can be vulnerable. Okay, if you don't, then that carboxylic acid will not be decarboxylated. Okay, so now there is a reaction in the reagent. There is acetate ion. So acetate ion just picks up the proton from the carboxylate ion, and here the CO2 get cleaves, we get decarboxylation, and this bond goes here and the OH cleaves, so we get a decarboxylated product. In this fashion, the Beckmann fragmentation occurs in this example. So let's move on to our next problem, where we are given an unsaturated oxime which is reacted with acetic anhydride. So at first, the acetic anhydride acidylates the OH group, and acetate ion from the acetic anhydride leaves in the reaction medium. So as you can see that these protons are very much acidic, because these protons are in this carbon and will be in conjugation. Okay, because there is unsaturation. Okay, so if the liberated acetate ion, which is a very good conjugate base, okay, so that acetate ion picks up this proton, and this bond goes here, this bond goes here, and we get this. Okay, so after that, so if this proton is abstracted by the acetate ion in the reaction medium, so that carbon ion will be also in the conjugation, which is stabilized. Okay, so that proton is again captured, and we get bond flow like this. So we get this as an again intermediate. And now what happens, if you closely look at this structure, this seems to be a tautomerized form of aniline. Okay, so to get these more stable and to get, so you can say that to get the aromatic stabilization, so this tautomerized into a more stable form, which is aniline. So we get aniline from this, and after that, you know that in the reaction medium there are acetic anhydride or acetic acid. So that just acetylates the aniline, and we get acetylated aniline as our final product. So these are the few problems which are very somewhat tricky or complicated in some way, or have some definite message through this problem, which are very important. And I have thought that this type of problem may come in CSIR NET or GATE exams. So let's hope that this will help you to understand better. So keep watching Learning Chemistry, and please follow our Facebook page, which is Learning Chemistry. Link is given in the description. And like, share, and suggest what you think, and suggest what I should improve or which topic I should make video the next time. So thank you.